Hello gems, welcome back to another video of the mock test series. This is the ultimate grind for BITSAT and today we'll be discussing paper number 6. So far we have already discussed up till paper number 5. If you wish to check them out, the links will be available in the description box of this video. So with every paper we actually tried something new. If you see, paper 1 and 2 were beginner level types, then we had paper 3 which was easy moderate category, paper 4 also easy moderate but a lengthy paper, paper 5 which was a lot conceptual, just the previous paper that we discussed. Now paper 6 is going to be sweet and sour and you are going to enjoy it. So with that being said, let the grind begin. So question 1 and 2 over here, let's hop straight into it. Thank God I didn't say dive. So question 1, an electron moves in the circular radius of this with a constant speed this. So uniform circular motion. This is happening due to a magnetic field. Okay, yes, there is a magnetic field which is perpendicular to the plane of the motion as expected. Okay, so there is an electron revolving in this plane, suppose, then the magnetic field is perpendicular to it. Okay. So that is why the circular motion is happening in first place, right? So what will be the value of the specific charge? Specific charge is basically E by M, okay, the ratio E by M. Okay, you can get the clue over here from the options. The option says the unit is coulomb per kg. Okay, so from there you can make it out that they are asking you for E by M. Here you are not supposed to directly compute E by M using E and M, the known values. Here you are given some data, through that you are supposed to find E by M. Okay, so don't use the known values. So how can we go about this? We can actually write the for the radius of a charged particle moving in a magnetic field will be mv by qb. Okay, the magnetic field is perpendicular, all the criteria are satisfied over here. So you are supposed to find E by M, right? E by M. So just take it to the other side. So that will be Q by M or E by M, in this case electron, right? So that will be V by RB. Okay. If you see, all of these quantities are given, velocity is given, radius is given, B is also given. So just substitute them and you'll have your answer. Velocity is this, radius is 10 and magnetic field is 10 to the power minus 5. This will become 10 to the power minus 4, go on top 10 to the power 4 and that will add with that. So 2 into 10 to the power 11. Okay, and that is in coulomb per kg. Okay, in SI units, that is option D. Okay, 2 into 10 to the power 11 coulomb per kg. Okay, don't do it by the known values, use R is equal to mv by qb. Okay, let's come to this one. Here we have two wires A and B of the same material having radii in the ratio this and current in the ratio this. You are supposed to find the ratio of the drift speed in A and B. Okay, so we are just supposed to know an equation that connects your current with drift speed, and that is I is equal to NEAVD, right? So I is the current and Vd is the drift velocity over here. Okay, so here we'll just take the ratio of these two wires, the current in these two wires. So Ia by Ib will be NEAVD and again NEAVD. Here the only two things that will differ is area, so I'll write dash dash over here for the second quantity. Ne will not change. E is charge on the electron, which is same for both the wires irrespective of the wires, and N is the number density, number of electrons per unit volume. Since the two wires are made of the same material, number of electrons per unit volume will be same, so Ne will cancel Ne. Okay, the only two things that are differing are area because of the radius are in different ratio, and Vd will change. Okay, so here Ia by Ib, so that ratio we are already given. So current in the ratio 4:1, so 4 by 1. Okay, and area is proportional to R square, right? So this we have to write in terms of R square, so 1 by 2. So I think yes, it's 1 by 2 and that will be squared. Okay, this is for radius. Okay, radius square is proportional to area, so we have to write it. So basically you can write area as pi R square and divided by pi R dash square, right? So now the radius are in the ratio 1:2, so that's squared. Okay, and finally Vd, the ratio of which we are supposed to find, Vd by Vd dash. So this is what we are supposed to find, the ratio of drift speed. This is in A, this is in B. So this will be 4, go to the other side, that will be 16 by 1, right? So this is Vd by Vd dash, which is nothing but 16:1, option A. Okay, so I hope that was simple. Over to the next question. So question 3 and 4 over here. In question 3 we have a circuit of capacitors. We are supposed to tell what will be the charge on the 5 microfarad capacitor. Okay. Now here my thought process is simple. First of all, I'll find the voltage across the 5 microfarad capacitor. So I'll just use Q is equal to CV. Okay, I already know C. Once I find V, I can use Q is equal to CV and find the charge on that capacitor, right? So I can first imagine this will be 3 microfarad. Here we have 5 and 2 in parallel, right? So 5 and 2 in parallel makes it 7, right? In parallel you just add the capacitor, okay? It's opposite to that of resistance, okay? So if you see this branch is parallel, is attached in parallel, these two branches are parallel to each other. So here the voltage drop will be also 6. Okay, the voltage drop across this branch and across this branch is the same and it is equal to 6 volts. Okay, so the voltage difference over here is 6. Okay, so here across these two resistances, the voltage drop is 6 volts. Now we are supposed to find the voltage drop across this one. Okay, because here we have the 5 microfarad capacitor, right? So here how to find the voltage drop across this? Simple formula, V is equal to VC2 upon C1 plus C2. Okay, this is the formula to find the voltage across this capacitor or this capacitor for that any random purpose. Okay, so this is the voltage divider formula, if you know. So VC2 upon C1 plus C2. Okay, so the voltage drop across the 7, so I'll write it, across the 7 microfarad capacitor is given as total voltage into other capacitor. So other capacitor, so basically it's inversely proportional. If you see voltage and when you connect them in series, the charge is the same, okay, and voltage is inversely proportional to capacitor. That's why we are using VC2 when we are finding the voltage for this one, okay, VC2. So total voltage into the other capacitor, okay, so that is the logic behind it. So VC2 upon C1 plus C2, 3 plus 7, that is 10, okay, microfarad cancel. So finally you'll have an answer in what you say, volts, okay. So here you'll get, if I divide this 0.6 into 3, 1.8. So 1.8 is the voltage across this capacitor, okay, here the voltage is 1.8, okay. Yes, now if you see this 7 is made of two capacitors, which is 5 and 2 in parallel, right? So 5 and 2 in parallel, so each of them will have 1.8 across them, okay, because this 7 has 1.8 across them, and when you split in parallel the voltage remains the same. So it's 1.8 across this and also 1.8 across this, okay. So our job is done. We have found the voltage across the 5 microfarad capacitor, that is 1.8, and you can easily find the charge. Charge will be C into V, that is 5 microfarads into 1.8, okay. So 5 into 1.8, I think that is 9, okay. So I think that is 9, so 9 microcoulomb, okay. Yes, 18 5s are 90, right? So 9 microcoulomb because capacitor is in microfarad. Okay, yes, 9 microcoulomb is the correct choice over here. Let's come to this one. This is a simple one on your error, okay, percentage error type question. Okay, here you are given the equation for heat dissipated. You are supposed to actually know this, but it was given, thank God. Okay, so here the percentage errors in I, R and T are given as 2, 1 and 1 respectively. You are supposed to tell what is the maximum error in measuring heat. Okay, now whenever the terms are in multiplication, the relative or the percentage errors are added, right? That is what is the theory behind it. Okay, so delta Q by Q, I'll write this as percentage errors. Okay, so into 100 if you want to write it that way. So this is the percentage error in Q will be given as 2 times, now it is raised to 2. Okay, so 2 will come down and 2 times the percentage error in the current, okay, plus the percentage error in your resistance, okay, plus the percentage error in time. Here it's raised to 2, that's why 2 will come down. Basically when you do this you actually take log, okay, but this is the final result that you get. Okay, so that is into 100%. Okay, so when you take log, that 2 comes down, right? So the percentage error in Q, in heat, you are supposed to tell it will be 2 into percentage error in your current, which is 2%, 2 into 2, 4. Then we have here 1% error, here also in time the percent is 1%. Okay, 4, 5, 6. Okay, 6%. So option D again 6% is the correct choice over here. Over to the next question. So question 5 and 6 over here. In question 5 we have a boy who is pushing a toy box. Okay, he pushes it 2 meters along the floor by means of a force. The magnitude of the force is 10 newtons. The force is directed at an angle of 60 degrees with respect to the horizontal. You are supposed to tell what is the work done by the boy. Okay, this might seem too much, but let's picture it. It's just a matter of FD cos theta. Okay, so here if you see, we have the toy box. The boy is going to move it 2 meters along the floor. So this is the displacement that is happening in this direction, let us suppose. Okay, so the boy is applying a force of 10 newtons at an angle of 60 degree in the downward direction. Okay, so if you see, the angle over here with respect to the horizontal is 60 degree. Okay, so it's pushing it like this. Okay, so some component of the force is responsible for the forward motion. Okay, so it's pushing it a bit in a downward direction. Okay, and some component is responsible for the forward motion. Okay, if you see the cos theta component, right? So basically the work done over here is FD cos theta, right? So the force applied, the magnitude of the force is 10 newtons. D is the displacement is 2 meters. Okay, and cos theta is the angle between F and D, right? If you see, the angle between F and D is 60 degrees, right? Displacement is along the horizontal, along the floor, right? So along the horizontal, and your F is at an angle of 60 degrees with respect to the horizontal. So the angle between the two is 60, cos 60 half. Okay, so here have half, this and this will cancel. 10 joules is the work done by the boy on the toy cart, okay, or the toy box. Okay, so let's come to this one. Here we have to tell what is frequency proportional to. Okay, so what is the frequency of this oscillation proportional to? I think this was one of the homework question in the mock test series that was left to you. I had asked you whether these two springs are in series combination or are they in parallel combination. Okay, seems like you'll find your answer today. So the answer is they are in parallel combination. Okay, they might seem in series combination, okay, since they are connected kind of end to end, the mass is between, but they are in parallel combination. Here the differentiator between series and parallel combination is that in series combination the force is the same. Okay, so if you have two springs in series combination, the force on each of them will be the same, whereas if you have two springs in parallel combination, the extension will be the same. If you see, if I move this block delta x times delta x towards the spring, okay, the extension over here will be delta x, and the compression over here will be also delta x. Okay, so here in this case the extension is the same, right? So if you compress it, here it will be compressed delta x, and here it will be extended delta x. Okay, so they are in parallel combination. Okay, so basically the time period for spring systems is given as 2 pi under root m by k, okay, or k equivalent, okay, when we have spring systems. Okay, so the frequency which is just inversely proportional to this will be basically, so your frequency is inversely proportional to time, right? So basically it will be inversely proportional to, I can directly write proportional, I will just neglect 2 pi, okay, it's a constant, so k equivalent by m. Okay, so frequency will be proportional to this. What is k equivalent? I told you that they are in parallel combination. So in parallel combination, the springs you have to just add, right? You have to add their spring constants. Okay, it's just like capacitor. So 2k plus k, that will be 3k. So 3k by m. So your frequency is proportional to 3k by m. Okay, which is option A. Okay, so mind you, they are in parallel combination. Okay, over to the next question. So question 7 and 8 over here. Question 7 is an interesting one. Here we are going to drop a body of density rho dash into a lake of density rho. Okay, rho is greater than rho dash, which means the density of the body is less than the density of the lake. So the body will float. Okay, of course you have dropped it from a height. So what will happen? It will gain some kinetic energy, then hit the surface of water. Since it has some kinetic energy, it will go deep down. Okay, some distance it will go. It will travel some depth, okay, in the water, and finally it will come again up and float. Okay, so you are supposed to tell, neglecting all the dissipative forces, you are supposed to tell what is the maximum depth that your body sinks to before it rises back up. Okay, before it returns and floats on the surface. Okay, what is the maximum depth that it can reach? Okay, now first of all, it is dropped from a height h. Okay, so the velocity that it gains, okay, suppose this is the surface of water, it is dropped from a height h, right? So here the velocity just before striking the surface of water is under root 2gh, right? This is the, we'll treat it as initial velocity. Okay, this is the velocity with which it begins, and finally it is going to go deep. Okay, it's going to go into some, it is going to cover some depth because of this energy. Okay, it has some velocity, initial velocity, so initial kinetic energy. So it is going to travel some depth until finally the velocity becomes 0. Okay, so the finally the velocity will become 0 because there is some force on that. There is upthrust, right, acting on your object. Okay, its mass is suppose n. Okay, so upthrust is acting on that object, okay, which is pushing it up. Okay, and its weight is acting in the downward direction, but upthrust is more since the density of your lake is more. Okay, so yes, finally the velocity will become 0, and at that point the depth will be the maximum. This is the depth they are speaking about. Okay, this is the maximum that it can cover. After this it will again come up, okay, due to upthrust. Okay, so here what we'll do, first of all we'll find the acceleration in this region. Okay, here you see the force acting in the downward direction is mg, the weight of your body, and the force acting in the upward direction will ignore the viscous force and all. Here we are just supposed to take upthrust. Okay, upthrust I can write it as u. So basically here the net acceleration, or you can write the second equation, F net is equal to mg minus u, right? Mg minus the upthrust. Upthrust can be written as volume of the a body immersed, volume of the body immersed, density of the liquid. Density of the liquid is rho over here, so I'll simply write rho into g. Okay, so if you see here we have mass we can write it as density into volume, right? So here it's the mass of the body, right? So density of the body, which is rho dash into volume, okay, into g, okay, minus here what you'll get, volume rho into g. Okay, here we can similarly, force net will be mass into net acceleration. Again mass can be written as density of the solid, which is rho dash. Okay, this is the net force on m, right? So density of this body into volume, into its volume. Okay, so volume can cancel throughout, as you can see. So your net acceleration is nothing but it will be nothing but, so if you divide both of this by rho dash, you will be left with g minus rho by rho dash g, or you can take g common. G will be g into 1 minus rho upon rho dash. Okay, so this is the net acceleration on the body. Okay, now this is the acceleration that is responsible for slowing it down. Okay, this is actually retardation, not acceleration. Okay, it's slowing the downward motion of your body. Okay, so we can use v square is equal to u square plus 2as. Okay, finally, because final velocity we know is going to become 0. Okay, at the maximum depth. Initial velocity we know, yes. Acceleration we have just found out. Okay, so that was the whole point. We were finding out acceleration so that we could substitute in this in this equation and find s. Okay, s will be the maximum depth that is being covered. Okay, so v final velocity 0, u square that will be 2gh. Okay, and then we have 2as. Okay, 2 into acceleration. So acceleration is actually retardation, so I can use minus. Okay, so that will be g into okay, here we are getting acceleration as this, no? Okay, we are getting it as positive only, so we'll substitute that only. So it will be 1 minus rho upon rho dash into d. Okay, d is the maximum depth over here. You are supposed to solve this. You can cancel 2g. Okay, h will be, so we are supposed to find d, right? So h is equal to, this will be what can I do? So minus h, I'll get this over here, and this will be rho dash minus rho upon rho dash. Okay, so into d. Okay, so d will be, from here d will be you have to conserve space now, d will be h minus h rho dash upon rho dash minus rho. Okay, if you see rho dash minus rho is negative, right? Rho dash minus rho. Rho is bigger than rho dash, so this minus sign and that minus sign will get cancelled. Okay, so I can actually flip this up. Okay, take that minus sign in and flip that up. That will be rho minus rho dash. Okay, I've just flipped that up. Okay, so take the minus sign over here. Rho dash will become negative. Rho will become positive. Okay, so basically the depth is h rho dash upon rho minus rho dash, h rho dash upon rho minus rho dash. I hope the procedure was simple. First we found the net acceleration when the body is in water. Okay, that net acceleration we used it over here. We know that final velocity will be 0 at the maximum depth. Okay, and initial velocity we know it is falling from a height h, right? So it's under root 2gh, that squared, and 2g into 2as. Okay, 2as. So a is over here and s is the depth covered. Okay, so I hope that was simple. Let's come to this one now. So here we have a circuit. We are supposed to tell what is the current in the 2 ohm resistor. Okay, here we also have a capacitor. So basically you are just going to neglect it. Okay, why? Because every time if it's not mentioned otherwise, the capacitor will be in the steady state, and in steady state no current flows to that branch in which capacitor is connected. Okay, so this is just like a open circuit. Okay, no current will flow. Okay, the capacitor is fully charged and no current is flowing in that branch. Okay, so we are just going to treat it as a open circuit. Okay, this is a open branch. We are just concerned about this two now. Okay, so first of all let us find the current that is drawn from this battery. Okay, so first of all we will find the equivalent resistance. So 3 and 2 in parallel, so product upon sum, 3 into 2 is 6 divided by 5, 1.2 and 2.8, that will be 4. So 4 is basically your equivalent resistance. Okay, so just simplify it, it is 4 ohms. So I is equal to V by R. V is 6, R is 4, so 3 by 2, 1.5. So 1.5 is the current that is coming from the battery. Okay, again it will split at that junction. Okay, here there is no branch. Okay, it's good for nothing. Here it will split at this branch, right? Here this 1.5 amperes will split between these two. Okay, in some ratio, of course. So we are supposed to find the current in the 2 ohm resistor. Okay, again it's simple. The current in the 2 ohm resistor, if you remember the capacitor, there we found the voltage. Right here current is inversely proportional to resistance. Okay, so more current will flow in that basically in that resistor which has less resistance. Okay, so here I in the 2 ohm resistor will be total current. Okay, I'll write that as capital I. So total current times the other resistance R2 into divided by R1 plus R2. Okay, so total current is 1.5, other resistor is 3. Okay, and that divided by 3 plus 2 is 5. This is 15 by 5, that is 3.3.9. Okay, so 0.9 amperes. Okay, so which is option C. Okay, so option C, 0.9 amperes is the correct choice over here. Over to the next question. So question 9 and 10 over here. Question 9, it's a very simple question. Here we are given the equation of trajectory of a projectile motion. We are supposed to tell the angle of projectile is given by. Okay, it's actually so simple that I will do it without using my marker. Okay, yes, done. The correct answer over here is option B. God damn it, I was not supposed to use marker, but anyways, okay, it's very simple. If you see, you have to just compare this with your equation of trajectory. Okay, general equation, it says that y is equal to x tan theta into minus gx square upon 2u square cos square theta. Okay, so forget about this part. If you see tan theta, if you compare the coefficients of x, you'll directly see that tan theta is root 3. Okay, yes, option B, tan theta is equal to root 3 is the correct choice over here. Let's come to this one. Here we have an organ pipe which is open from both the ends. It produces 5 bits per second when vibrated with a source of this. Okay, so its fundamental frequency is around this frequency. Okay, so its fundamental frequency may be 200 plus or minus 5 hertz. Okay, so its fundamental frequency is in this range, right? That is why it is producing 5 bits per second. The difference between this and its fundamental frequency is of 5 hertz. 5. Okay, so that is why it is producing 5 bits. Okay, so either it is 195, I must say, or it may be 205 hertz. Okay, you are supposed to tell the frequency, fundamental frequency of this organ pipe. One more data is given, that second harmonic of this pipe produces 10 beats per second with a frequency of this. Okay, so first of all we can neglect certain options from here. 205, 195 are there, this and this cannot be true. Okay, so let's come to the other one now. Here the second harmonic of the pipe produces 10 beats per second with this frequency. Okay, so in that case the second harmonic is 2 times of f, right? This is a pipe which is open at both the ends, so all the harmonics are present, so second harmonics is 2 times of f. If we had a pipe which was open at one end, then in that case it would have been 3 times of f. Okay, in that case only odd harmonics are present, so it's like 1, 3, 5. Okay, here it's 1, 2, 3, 4, 5. So here the second harmonic means 2. Okay, there it means 3. Okay, let's come back. So 2f will be 420 plus or minus 10. It produces 10 bits. Okay, so the second harmonic and the difference between the second harmonic and this one is around 10 bits. Okay, so 10 hertz. Okay, so here you'll get either it is at 430 or 410. Okay, if you divide this by 2, okay, because we want f, this will give you 2, 42 half is 210, so 215 maybe, and right, yes, and here 40 half is 200, 205, so 205 hertz. Okay, so if you see only 205 hertz is the organ pipe, okay, that satisfies both the conditions. Okay, this pipe will produce 5 hertz with this one, with the first source, and it will produce 10 hertz with the second source. Okay, the rest of them does not satisfy both the condition. 205 satisfies both the condition, which means that 205 is the fundamental frequency of this organ pipe. Okay, yeah, that's our answer. Over to the next question. So question 11 and 12 over here. In question 11 we are told that the escape velocity from a planet is v and a tunnel is dug through the diameter of the planet, just like that. It's a very simple job, and a small body is dropped into the surface. Okay, it's dropped in this tunnel. Okay, so suppose we have a planet like this and we are going to dug a hole through it. Yeah, very simple job, and we are going to drop a body, a small body, in this hole. Okay, you are supposed to tell what will be the velocity of this body when it reaches the center of the planet. Okay, so first of all you must realize that this body will execute SHM, right? Tunnel through earth is one of the concepts of SHM, if you see. Okay, so this body is going to perform SHM, its mean position being the center of the earth. So basically at the center of the earth it is going to acquire its maximum velocity. Okay, because it is its mean position. Maximum velocity in case of SHM is given as a omega, right? This is the maximum velocity in SHM, right? A omega. Okay, so a will be nothing but radius of this planet, right, which is r. Okay, we'll consider that as r, and omega over here will be omega can be written as 2 pi by t. Okay, and do you know the time period of this? It's around 82, 83 or 84 seconds maybe. I don't remember it well now, but the time period is around 80ish something. Okay, so basically it is given as 2 pi under root r by g, and this value if you compute for earth it is 80ish. Okay, so yes, omega first of all you can write it as 2 pi by t. So this is 2 pi by t, and t you can itself write it as 2 pi under root r by g. Okay, so basically we started with V max is equal to a omega. A we replaced with r, and omega we replaced it by 2 pi by t. Okay, and t we replaced by this thing now. Okay, so yes, that is how we did it. So we reached over here. 2 pi will get cancelled, and what do we have? We have this g will go on top and under root r. Okay, 1 under root r will cancel that, so we are going to get this. So basically escape velocity, if you want to write it in terms of g and r, it is basically under root 2gr for any planet. This is g is maybe the acceleration due to gravity, and r is the radius of that planet. If you see, compare this two, okay, you can easily see that this velocity, the velocity at the center is ve by root 2, right? If you divide this by root 2, you will get this. Okay, so if you divide this by root 2, you will get this. Okay, so the velocity at the center is option B, ve by root 2. Now let's come to this one. Here we are going to introduce a sheet of glass. This is this has refractive index as shown, okay, and the thickness is this 6 microns, 6 into 10 to the power minus 6. Okay, we are going to place it at one of the interfering beams. Okay, so that creates a path difference, if you know the concept, and the central bright, so basically that creates the path difference between the two interfering beams, and basically the central bright is shifted to another position. Okay, here in this case the central bright shifts to a position previously occupied by the fifth bright fringe. Okay, so basically central bright is shifted to the fifth bright fringe in the original case when the sheet was not introduced. Okay, so let's find out what is the wavelength of the light used. Okay, so first of all, the shifting in the case of central bright is given as mu minus 1 t lambda capital D by small d. Okay, basically mu minus 1 into t is the path difference that is introduced due to this thin sheet. Okay, so that into lambda capital D by small d. Okay, this is the position of the central bright when the sheet is introduced. Okay, and here we are told that y. Okay, so basically this position of the central bright is equal to the fifth position, okay, in the initial case. So n lambda capital D by small d. Here n is 5, right? This is the position of the fifth bright fringe. What am I doing? Okay, so this is the position of the fifth bright fringe in the original case. Okay, so you can cancel this. Okay, no lambda over here, just a mistake. So this and this will get cancelled. Okay, now finally we'll be left with lambda is equal to mu minus 1. So 1.5 minus 1, that is 0.5. Thickness is 6 microns, 6 into 10 to the power minus 6 divided by 5. That will make this 0.1, 0.1 10 to the power minus 7. So 6 into 10 to the power minus 7, or 6000 into 10 to the power minus 10, or 6000 angstroms. Okay, so the basic concept you are supposed to use, this is the shift that is caused in the central bright. That shift you have to equate to the fifth bright, the position of the fifth bright fringe. Okay, equate that and substitute and solve for lambda. That's the simple job. Okay, so let's move to the next question now. So question 13 and 14 over here. Question 13 is a very simple question. In this question we are told that a conducting square loop like that, it has a resistance R, it is moving with a uniform velocity which is perpendicular to one of its sides, as you can see. So the magnetic field is present everywhere and it is constant in space and time. So there is a constant magnetic field directed in the inward direction. Okay, so yes, you are supposed to tell what is the current induced in the loop. Very simple question, and this is one of those questions that I can do without using my marker. Okay, if you remember the previous one, right? So here the correct choice is option D, not falling for that again. Okay, so option D is the correct choice, and now I will use my marker. Why option D? Because if you see the magnetic field is constant. The EMF is only induced if there is a change in the magnetic flux, right? Minus d phi by dt. Okay, so if the magnetic flux changes, if the density, okay, the number of field lines changes, then only the EMF is induced, and if the circuit is closed, then only the current will flow. Here in this case, the magnetic field is uniform. It is uniform in space and time, constant in time and space. Okay, so the magnetic field is uniform. So even when you move across that field, same number of lines are passing every time. Okay, so there is no flux change. Okay, so no EMF induced. So the current, no current induced. Okay, so current is 0. Okay, let's come to this one. This is a very conceptual one. Okay, here we have a mass of 2 kg which is placed on a horizontal surface. static friction, the coefficient is this. Static friction, the coefficient is this. Kinetic friction, the coefficient is this. If the force applied on the body is this, you're supposed to tell the frictional force acting on the body. Okay, so first of all, let's find the limiting friction. Limiting friction is basically the maximum value of the friction. Okay, basically friction is, if you know, it's a variable force. Okay, static friction is variable. Okay, so limiting friction is given as the coefficient of static friction times n. Okay, n is basically mg over here. So mu s is 0.5, m into g. So m into g, I'll take it as 10. So this will become 5, and again 5 to that 10. Okay, so that is 10 newtons, right? So yes, so 10 newtons is the limiting friction. This is the maximum friction that your surface can provide. Okay, but you are applying a force of 2.5 newtons on the block. Okay, so this is the surface. You are applying a force of 2.5 newtons. Okay, so what will happen? Will the frictional force be 10 newtons? If it was 10 newtons in the opposite direction, of course the block would move in the opposite direction, right? You applied a force at 2.5, but the friction is 10, so it's moving in the opposite direction. That does not make any sense, right? If you have a little bit of common sense, which I'm sure you have, don't unsubscribe. Okay, so yes, if you see, friction is variable. Okay, so static friction is variable. So if you apply 2.5, the frictional force will be also 2.5. Okay, that is the reason why your thing does not move. Okay, so if the coefficient of friction between this pen and my hand is 10 newtons, as in this case, if I push it by a force of 2 newtons, nothing will happen. Okay, the frictional force acting on it is also 2 newtons. That's why the two forces are cancelling and you have no net motion. Okay, so option D, 2.5 newtons is the correct choice over here. So the limit of this force, the maximum force that the friction can provide, the friction between hand and this, is 10 newtons, right? So if you apply a force greater than 10 newtons, then only your pen will move. Okay, then only the body will move. Okay, so if you apply a force less than 10 newtons, okay, an equal and opposite force will be generated by friction, and that will cancel the any force. Okay, up till 10 newtons. If you apply greater than 10 newtons, of course your body will start moving. Okay, in other cases it just cancels the force. Okay, whatever it is, for less than cases. Okay, any force less than 10 newtons will be cancelled by the frictional force. Enough of talking. 2.5 newtons is the correct choice over here. Over to the next question. So question 15 and 16. In question 15, from a 200-meter high tower, we are going to throw a ball. First ball, we are going to throw it upward with a speed of 10 meters per second. Another ball, we are going to throw it with the same speed, but we are going to throw it down. Okay, so first we'll throw it up. Okay, this we are going to do simultaneously. So the first ball will go on a journey like this, and the second ball will be just thrown down with the same speed, okay, which is 10 meters per second. So it will go on this journey. Okay, so you are supposed to find the time difference between them reaching ground. Okay, so we are going to do this simultaneously, and you are supposed to find the difference between them, right? This first ball is taking a bigger journey, so of course it will require some greater time. Here it will require some less time. Okay, so you are supposed to find the difference between them. Okay, so first of all, you can see, you can split the journey of ball 1 into two parts. One when it goes up and comes down till over here, okay, to the same level, and here the speed will be 10 meters per second in the downward direction. Okay, so if you see this and this, the second part of the journey of the ball 1 is identical to the first part, to the journey of the second ball. Okay, so if you see the first ball, I've divided its journey into two. First, when it goes around, okay, it goes up and comes down to the same level. So when it comes down to the same level, it will gain the same speed, but in the opposite direction, which is 10 meters per second. So this journey from here to here is identical to the journey of the other ball. Okay, so this time is the same. Okay, the only difference which is caused is due to this journey. Okay, where it's going up and coming down. That there the difference is caused. Okay, and what is that time? That is nothing but the time of flight, right? Time of flight in case of your in case of motion and gravity. Okay, this is not projectile motion, this is motion and gravity. It's happening actually in 1D. Okay, I've just exaggerated it. Okay, so this will be given at 2u by g, okay, or basically 2u sine theta by g, and theta is 90 degrees, okay. The angle is, it's thrown vertically upwards, right? So basically the time of flight over here is 2u by g, sine 90 is 1, right? So 2u, 2 into u is 10, by g is 10, this and this will get cancelled, 2 seconds, okay. So this is 2 seconds, okay, and whatever this time may be, this will be suppose t2 and this is also t2, okay. So the difference is of 2 seconds, okay. So the correct choice over here, the difference between the two motions while reaching the ground will be 2 seconds, okay. So you can also find the difference like 2 plus t2 for this journey. For the first journey it will be 2 plus t2, and for the second journey it's simply t2. So the difference is 2, okay, no need to do that, the answer is 2, okay. Let's come over here. Here we have three charges, q, q and 4q, okay. Q, capital Q and 4q, they are aligned in the same line, okay, in a straight line, and at distances 0, L by 2 and L respectively. So let's imagine that. So Q is at 0, capital Q is at L by 2, okay, and 4q is at L, okay. So in order to make the net force on Q is equal to 0, so here you are supposed to make the net force 0, okay. You are supposed to tell if the net force on Q is 0, what must be the charge on this Q, okay, in terms of small q, okay. So first of all, you can easily realize it that the charge on Q, the capital Q, should be negative, right? Because if you see 4q is pushing this charge outward, okay. If the charge on Q, this capital Q, is also positive, it will also push the charge small q, right? And there is no chance of cancelling. Whereas if the charge on this capital Q is negative, it will pull, and there is a chance that these two forces will be cancelled, okay. So the charge on Q must be negative, okay. So option D we can neglect now, okay. So the charge should be negative, and of course the net force should be 0, okay. So basically the force force on this charge due to this charge is equal to force on this charge due to this charge, okay. So you are just supposed to equate the forces, okay. So the force on Q due to Q, first of all, so that will be K Q Q, okay, force on Q due to this Q, okay. So Q Q Q, okay, K Q Q, okay, K Q Q, okay, and that divided by L by 2 the square, okay, kq1 q2 by r square, okay. And that force, if you want to write the negative sign, you may as well, because it is attractive in nature. And here what will be it will be k 4q into q, okay, this and this, okay, force on this charge due to this charge, okay. So 4q into q, q1 q2 by r square, r is L square, okay. So k and k can get cancelled, q will also get cancelled with q. So q L square will also get cancelled. This will become 4 will go on top, okay. This will be minus 4q is equal to 4q, okay. So q is basically minus of q. Yes, option A, minus of q, is the correct choice over here, okay. So you are just supposed to equate the forces, negative sign here because it's attractive in nature. This q should be negative, or you directly find the magnitude, okay, directly find the magnitude of q. It will be equal to q, and you know it should be negative, okay. That way also you can see, okay. So yes, minus q is the correct choice over here. Over to the next question. Question 17 and 18 over here. In question 17, we have a vessel with water. It is weighing 600 grams on a weighing pen. Now we are going to immerse a ball with density this and mass 40 grams in this water. Now of course the density of your ball, if you see, is less than water, okay. So it will try to float, but we'll keep it sunk by using a pin of negligible volume, okay. So we are just going to push the ball into the water with a pin of negligible volume that does not contribute to the reading on the pen, okay. So you are supposed to tell what will be the reading on the pen now, okay. Now that you have immersed a ball of 40 grams, okay, will the reading change? Yes, of course it will change, okay. So what will happen is that when you immerse the ball in the water and you held it, okay, you hold it sunk with a pin, okay, what will happen? There will be some upthrust on this ball, or conversely this ball will put some down thrust on water, right? Forces exist in pair. For every force there is an equal and opposite reaction. For every action there is an equal and opposite reaction. So basically for up thrust we have down thrust. Okay, so this down thrust of course will act on water. Okay, up thrust acts on the ball, okay, and down thrust will act on the water. Okay, so down thrust will act on the water, and we also have the mass of water. Okay, mass of water or its weight mg. Okay, so basically the net force on water, F net, this is on water, will be basically the down thrust plus mg. Okay, now down thrust will be nothing but volume immerse rho into g, right? It's same as up thrust, both of them are equal but opposite. Okay, so it's same as v rho g. Okay, rho being the density of the liquid. Okay, v is the volume immersed. Volume immersed can be written as what can we use? Volume can be written as density is mass by volume, so volume is density mass by density. Okay, so you can find actually the volume of this. Okay, first of all I'll write it as v rho g plus mg. This is the net force on water. Okay, now volume can be found out as mass by density. Mass of the block is 40, the ball is 40, and the density is 0.8. Okay, so 40 I can multiply it by 10, that will be 400 by 8, 8 5s are, so 50. Okay, 50, so that will be 50 centimeter cube. Okay, everything is in CGS. So here the volume is 50 centimeter cube. Density of water, now this is upthrust, density of water, okay, density of liquid. So here it is 1. Okay, g will keep as it is, plus g I'll take common. Okay, and plus the mass of water. Mass of water is 600. Mass of water initially is 600, right? So 600 into 50, 600 plus 50, that is 650 into g. Okay, this is the reading that your reading scale will show, your weighing scale will show. That is option C, 650 grams. Okay, this g is not grams, this is acceleration due to gravity. Your weighing machine just shows you the mass equivalent of your weight. Okay, so basically if you have 650 g, your weighing machine will divide this reading by g and it will tell you the mass. Okay, so basically g and g will get cancelled, it will only show you the mass. Actually weight is a force, right? So the answer should be in newtons, but yeah, it is in grams because your weighing machine is doing some manipulation over there, right? So yes, your weighing machine just shows you the mass equivalent of the force which is applied on it. Okay, anyways, let's come to this one. Here we are supposed to tell the shortest and the longest wavelength for the Lyman series. Okay, now Lyman series, everything will come down to 1, right? N2 will be 1, N2 will be 1. So basically if you know the formula, the Rydberg's formula, 1 upon lambda is given as R into 1 minus N2 square minus 1 upon N1 square, right? So basically N2 is 1 throughout the Lyman series. Okay, finally the transition comes down to 1 in case of Lyman series. Okay, so here lambda max, first of all let's find the shortest wavelength. Shortest wavelength will be given by the longest transition. Okay, largest energy gap, shortest wavelength. Okay, energy and wavelength are inversely proportional, right? So largest energy gap, so it will be from n1 will be infinity. Okay, and n2 will be your 1. Okay, n2 is always 1 in case of Lyman series. So this is the minimum wavelength, the shortest wavelength. It will be r into 1 minus 1. Okay, that is 1 minus 1 upon infinity square. Now this will be of course 0, so you just get lambda minimum is 1 by r, right? This is 0 and this is again 1 into r. So lambda minimum is basically the reciprocal of that, 1 by r, and if you know 1 by r is basically 910 angstroms or 912 I guess. Okay, so something like that, 910 angstroms. Okay, so shortest wavelength is this and longest will prove it as that. So longest wavelength, okay, the maximum one will be r only n1 and n2 will change. N2 will not change, it's Lehman series. So 1 and n1 will change. Now for longest wavelength it will be the shortest transition. Okay, energy wavelength opposite, right? So inversely proportional. So the longest wavelength will be for the shortest energy transition. Okay, so it is from 2 to 1, that is the shortest one, right? 2 to 1, everything has to come down to 1. Okay, in case of Lehman series, so it's from 2 to 1. So 1 upon 2, that is squared. Okay, so 1 minus 1/4, that will give you 3r by 4. 1 minus 1/4 is 3/4, so 3r by 4. So your lambda max is nothing but 4 by 3 times 1 by r. So 1 by r you already know, it's this, and into 1.33, that will be around 12.13. So option A is the correct choice over here. Okay, I hope that was simple. Over to the next question. 19 and 20 over here. In question 19, we again have a vessel now of depth 2d. Okay, one half is filled with, so d amount is filled with a refractive index of mu1, another half is filled with a refractive index, so the upper half is filled with a refractive index of liquid mu2. Okay, you are supposed to tell what will be the apparent depth due to this combination of liquids now. Okay, actually there is a small derivation behind this. You are just supposed to take 1.0 over here. Okay, find the apparent depth at this surface, so at this surface first, and suppose you find it at as d dash. Now this will act, now this image will act as object for mu2. Okay, so again you'll take this as real depth and the apparent depth somewhere over here, d double dash, so that will be the net one. Okay, so there is a short derivation behind this. Okay, it's not so short, that's why I'm skipping it over here. Actually we did it in one of the problems of A series. If you want to check it out, I'll put the links over here. I think it's question 13 if I'm not wrong. Okay, so do check it out. So the end result that we get, which is the net apparent depth. Okay, net apparent depth due to this two liquids is given as d1 by mu1 plus d2 by mu2. Here d1 and d2 are the same. It's basically d, so you can just erase it off. So d and d. Okay, so in general it's d1 by mu1 plus d2 by mu2, or if you have more, it's d3 by mu3. Okay, so here d you can take common, 1 upon mu1 plus 1 upon mu2. Okay, so option B is the correct choice over here. If you're curious how did we get this, do check out the video, don't take my word for it. Okay, so now in question 20 we have a nucleus which splits into two halves, two nuclear parts. One, their velocities are in the ratio 2:1. You are supposed to tell what will be the ratio of their nuclear radii. Okay, so first of all let's conserve momentum, so that will give us the ratio of masses as 1:2. Okay, opposite. If you see final momentum is equal to initial momentum, we'll assume that initially your nucleus was at rest. So m1 v1 plus m2 v2, the two parts, these are the two final parts, right? m1 and m2. So nucleus is, suppose capital M, it's at rest initially, it splits up into m1 and m2. Okay, it is moving with v1 and this is moving with v2. So initial momentum is 0, since initial velocity is 0. Okay, final it's m1 v1 plus m2 v2. This two velocities actually will be in opposite direction. Okay, you'll see a negative sign over here. So m1 v1 is, if you take it as 2, it's in the ratio 2:1. Okay, so I can write actually m1 v1 is equal to minus m2 v2. Okay, I'm just simplifying it forward. So m1 by m2 will be nothing but v2 by v1, and that minus sign because the two velocities are in the opposite directions. Okay, so you can actually neglect that. So v2 by v1 will be 1:2. Okay, v1 by v2 is 2:1, so v2 by v1 will be 1:2. Okay, this is the ratio between the masses m1 by m2. Now this will be the mass will be directly proportional to your atomic mass number, right? More the mass, more the atomic number, right? So I can directly write it as a1 by a2. Okay, and if you know a1 by a2, a is directly proportional. Okay, your radii is directly proportional to a to the power 1/3. Okay, so I can find r1 by r2. So r1 by r2, if you want to take this ratio, it will be equal to a1 by a2 to the power 1/3. Okay, now you directly know that a1 by a2 is half, right? From here you directly know it as half, and that will be raised to 1/3. So the correct choice over here, simply it's 1 upon 2 raised to 1/3. Okay, 1/3 means cube root. So option B, 1 is to 2 upon 1/3. Okay, 2 raised to 1/3. Okay, so option B is the correct choice over here. Over to the next question. 21 and 22 over here. In question 21, we are given the displacement equation of an SHM. Okay, you are supposed to tell its speed will be maximum at time. Okay, so at what time will its speed be maximum? Okay, so basically you'll know that the maximum speed of an SHM is acquired at the mean position when x is equal to 0. Okay, so basically you are supposed to make x is equal to 0, or you can differentiate this, get the velocity expression, and basically you are supposed to maximize it. Okay, or here x is equal to 0 would also do. This is the mean position, right? At mean position the velocity is maximum, so you are just supposed to make x is equal to 0. Okay, a is constant, it cannot be 0. Here this term can become 0, right? Cos of something can become 0. Cos of what can become 0? 90, right? So yes, you have to make this angle equal to 90. Omega t plus pi by 4 equal to 90. At that instance, your x will be 0 and your particle will be at the mean position and will have the maximum velocity. Okay, so basically omega t is, this is 90 minus 45, that will be 45. Okay, and t will be nothing but pi upon 4 omega, which is option E. Okay, let's come to this one. This is a good one. Here we have a solid and a hollow sphere. This is one of the favorite topics of your BITSAT 2, rolling down the incline. Okay, so here we have solid and hollow sphere, both of same mass and external diameter. Okay, so their geometry is the same and mass is the same. They are released from a height, so they will be rolling down some incline. Okay, they are released simultaneously. You are supposed to tell which one will reach the bottom first. Okay, and actually it's not both together, neither it's data insufficient. Okay, try to guess it if you can. Okay, it's very simple. You must know the concept that acceleration down an incline, when your body is rolling without slipping. Okay, it's rolling, so pure rolling. So here we have g sin theta upon 1 plus I square plus mr square. Okay, or k square by r square. Okay, radius of gyration. Okay, so here we'll split it up into solid and hollow. So remember that the one that has higher acceleration will reach the bottom first, right? It is accelerated fast as compared to the other. So higher acceleration, lesser time. Acceleration and time are inversely proportional. They are beginning at rest. Okay, so the one which is accelerated faster will reach the bottom first. Okay, so with that being said, let's do it. So A will be equal to g sin theta. Theta is the angle of inclination. 1 plus I for solid sphere. For solid, sorry, not sphere, solid cylinder. Solid cylinder is, if you compress it, it's just like a disc. Okay, it's just like a disc. So we have mr square by 2. So mr square by 2, and here mr square. Okay, mr square gets cancelled. G sin theta upon 1 plus 1 by 2, that is 3 by 2. So that will be 3 by 2. 2 will go in the numerator, 2 by 3. Okay, so this is the acceleration for the solid one. Let's compute it for the hollow one. That will be g sin theta upon 1 plus the moment of inertia for a hollow cylinder. Hollow cylinder is just like a ring. Okay, it's just like a ring. So it's simply mr square and mr square will get cancelled, and it is g sin theta divided by 2. Okay, 1 plus 1, that is 2. So here you will get, so if you compare these two, which one is greater? This one is greater, right? This is around 0.5 g sin theta, 0.5 g sin theta, right? Whereas this is 2 by 3 is 0.67 g sin theta. So easily you can see that the acceleration for the solid one is bigger, so the time taken for the solid one, solid cylinder will be lesser. Isn't that amazing? So over to the next question. In 23 and 24 over here. In 23 we are told that the forward voltage in a semiconductor diode is changed from this to this, then the forward current changes by 1 milliamps. So you are supposed to tell what is the forward resistance of the diode. Okay, Very simple. You are just supposed to know the dynamic resistance formula. You might have seen it in your NCRT. It's basically like Ohm's law. Okay, delta V by delta I. Okay, delta V is equal to IR. Okay, so that way. Okay, so it's the same thing here. Basically, it's the dynamic resistance for a diode. So here, if you see delta V, the change in voltage is this to this. So 0.7 minus 0.5. Okay, divided by the current change is 1 milliamps. So the change in the current is 1 milliamps. That is what is told. So 1 into 10 to the power minus 3. So this is 0.2, and 10 to the power minus 3 will come on top. That will become positive. Okay, and that will be 200 ohms. Okay, yes, everything is in SI. So option C, 200 ohms is the correct choice over here. Okay. Let's come to this one. We are supposed to tell the moment of inertia about this axis, which is at a distance r by 2 from this circular loop. Okay, this circular loop has a radius r as told. Okay, so here you are just supposed to use your parallel axis theorem. Parallel axis theorem says that the moment of inertia about any axis, suppose this is that any axis, so the moment of inertia about that axis is given as the moment of inertia about an axis which is passing through the center of mass plus mass of the body times the distance between the two axes squared. Okay, I'll repeat that. The moment of inertia about an axis is given as the moment of inertia about a parallel axis that is passing through the center of mass plus mass of the body times the distance between the two axes. Okay, so simply substitute it. Now ICM will be this, right? This is the center of mass. Okay, so yes, the moment of inertia about this axis now. Okay, it's we have a loop like this about this axis. Okay, so that will be mr square by 2 if you can remember. Okay, the moment of inertia of a ring about the diameter. Okay, about if the axis is perpendicular to the ring, the moment of inertia is mr square. If it's along one of the diameters, it is mr square by 2. Okay, so plus mass is m, we have considered it as m, and d square, the distance between the two, that squared. So r by 2 square, that will be r square by 4. Okay, so if you take the LCM, that will be 4, and that will be 2 plus that 3, so 3 mr square by 4. Okay, so 3 mr square by 4. So option B is the correct choice over here. Okay, so two simple questions over here. Over to the next question. So question 25 and 26 over here. In question 25, we have an adiabatic process happening and the pressure is increased by this percentage. If gamma is this, you are supposed to tell what is the decrease in the volume. Now you might do it by the conventional way by equating P1 V1 raised to gamma is equal to P2 V2 raised to gamma, and then solving it, taking the ratio and all. But that would take a long. Here the pressure difference is small, so actually we can use the log method. Okay, what I'll do, I'll write PV raised to gamma is constant. Okay, so PV raised to gamma is equal to some constant K for adiabatic processes. Now I'll take log of P plus gamma. Okay, log of V raised to gamma. Now using the properties of logarithm, you can bring gamma over here, you can bring it down, and this will be log of K, right? So now differentiating, we'll get 1 upon P dP, right? Here for log of V, you'll get V upon, so 1 upon V dV, and here K upon 1 upon K dK, right? No. Now here log K is basically constant, right? Differentiation of a constant is 0. Okay, so that was the catch point. Here you are just supposed to solve now. Now dP, you know, the change in pressure is 2 by 3%. So first of all, let's make it simple. Okay, what I'll do, I'll take it to the other side, dV by V. This is what we are supposed to find, right? The decrease in the volume. So dV by V is what we are supposed to find, minus dV by V, that is decrease. So dP by P into 1 by gamma. Okay, that will give us this decrease in the volume. Okay, so it will be given as 1 by gamma, so 2 by 3. Okay, and the change in pressure is also 2 by 3%. Okay, so this is 4 by 9%. Okay, so if you had to do it by the ratio way, that would have taken long. Okay, so especially for small changes, prefer the log method and differentiation. Okay, it works for small changes. Okay, the 2 by 3 is a small change in pressure, right? So yes, option A is the correct choice over here. Let's move to this one now. Here we have to tell the potential energy of a satellite of mass m, which is revolving at a height re. Now mind you, re is the height, okay, from the surface. Okay, so re is measured from the surface. Okay, so here we have re. Okay, and if you see the distance from the center, it will be 2 times of re, right? Re plus re. Re is the radius of the earth. Okay, so height from earth is re, and this is also re, okay, from the surface. So the total distance of the satellite from the center of the earth is 2 times of re. Okay, you are supposed to tell its potential energy. Now it's very simple, it's minus gmm by r, where small r is the distance from the center. Okay, so it's gm. You can actually write gm as gr square. Gm is equal to gr square. Okay, because everything is in terms of small g over here. Okay, so you can write it as gr square. Okay, re square. Okay, your re for radius of earth, and capital M. Okay, gm is gone. Okay, gm is gr square. So capital M is gone. Small m upon radius in which your satellite is orbiting. It is 2r. R is measured from the center. So yes, you get it as minus mg re by 2. So mg re by 2, which is option B. Okay, I hope that was simple. Over to the next question. So question 27 and 28 over here. In question 27, we have a charge q, okay, plus q, which is placed at a distance L by 2 from a square lamina. The square lamina itself has a side L. Okay, you are supposed to tell what is the flux linked with this surface. Okay, you cannot solve this question directly. First of all, you'll have to draw a cube around this spherical, around this charge. Okay, so suppose we have the charge q over here. We'll draw a cube around it, just like this. Okay, and you'll see that the charge will be at the center of this cube. Okay, just because it is at a distance L by 2 from the one of the faces. Okay, so this is one of the face. I'll shade it, the bottom one. Okay, this is the one that we are supposed to find the flux through. Okay, so yes, it is at a distance L by 2 from that face. So due to symmetry, it will be at a distance L by 2 from each of the faces. Okay, provided it's at the center of that face, like that. Okay, so yes, our charge q is at the center of our cube. Okay, and by Gauss law, you can simply say that the flux linked with this, so the flux linked with this is q by epsilon naught. Okay, the charge enclosed divided by epsilon naught. Now it's simple to see, as I have mentioned, that the charge q is at the center, right, of this cube. So the flux is uniformly distributed among the faces. Okay, and there are 6 faces for the cube, right? So this flux, this entire flux is divided among 6 faces. Okay, is distributed uniformly among 6 faces. So each face will get 1/6, right? 1 by 6 of the total flux. Okay, so basically your answer over here, the flux linked with one of the face, one of the square lamina over here, is q upon 6 epsilon naught, since the flux, the total flux, is distributed among 6 faces. Okay, so let us come to this question now. We have an electromagnetic radiation which is used in food processing sterilizing agent, as a food processing sterilizing agent. Okay, so you are supposed to tell such a radiation, and the answer over here is option B, UV rays. Okay, don't ask me why. This is a theory based question. You're just supposed to know it. There is a table, in fact, on your NCRT that tells you about the uses of different electromagnetic radiation. So you have to by heart that. Okay, so here the electromagnetic radiation used in food processing is UV rays, maybe because it kills the germs and the bacteria. Okay, although the dead body remains over there. Okay, what a funny thing. Okay, over to the next question, which will be your homework questions. Question 29 and 30 over here, these are your homework questions. You can pause the video over here, take a screenshot, okay, and do let me know the answers in the comment section. The question 29 is a bit tricky. Do let me know which concept you use in order to solve this question. Question 30 is simple. Okay, so I think that's pretty much it for today's video. I hope you enjoyed it. If you did enjoy it, smash that like button. I'll see you soon in the next video. Till then, keep enjoying physics.